Hello everyone, welcome back to Pseudocoder. My name is Ravina and today we are going to learn another data structure called heaps. Okay, so what is heap? Heap is a binary tree where a parent is always smaller than its children. So we have seen in binary trees that, nodes on the left are less than the parent, nodes on the right are greater than the parent. But here in heap, you have to have a parent node which is always smaller than your children node. Okay, so let's see what is the structure of the heap. So for example, let's say we have this heap where we have 1 as the root, then you can have, two other nodes, 2 and 3. So 2 and 3 are actually greater than the parent node. That works. Then we can expand further. We can say, we have 4 and 5. We have 6 and 7. Here you can see that the parent node here is always smaller than its children. So 1 is smaller than 2 and 3, correct? 2 is smaller than 4 and 5, correct? And 3 is smaller than 6 and 7. Okay, so that is a heap. So in Python, we actually have a module called heap q that is used to implement the heap. Okay, so this is how it looks in a tree structure. But the module heap q that is used by Python actually uses it from a list. Okay, so how does that work? How can you have a heap inside a list? Let me show you pretty quickly. So let's say we have this list here. Now what happens is you have numbers in such a way that you have one node here, and then you have 2, 3, 4, 5, 6, and 7. And let me show you the relationship now. So 1 has 2 children, 2 and 3. 2 has 2 children, 4 and 5. So 2 is here and it's pointing to 4 and 5. And lastly, 3 has 2 children, 6 and 7. So this is how you can represent a heap in a list. And we will see very shortly in the code how can you use that heap q module to actually implement heap. So let's move on to our IDE and understand that. The first thing here that we have to do is actually import the module. Okay, so for that, what I can do is I can write the keyword import and then the name of the module. So in this case, it is heap q. Let me correct that spelling. Okay, heap q. Okay, so now that I have now imported the module, let's now try to define it. So there are two ways of defining a heap. One is by creating an empty list, and the other way is by using a method that is provided by the heapq module, Heapify. Okay, so and that Heapify method is actually used for, if you have a list that you already have populated that list, then you can use that method. So now let me show you first the first way of doing it, that is just by initializing a list. So here what I can do is I have a list called heap. So this is how you initialize a list. And now what you can do is you can simply use this particular list as part of your heap q module when you want to pop things, push things out of the heap. Okay, and say for example you have another list. Say you have something called heap 2, or I can actually call it numbers. So say you have numbers, and here say you have something 3, 4, 7, 1, 2. Now, what if you already have the list and you want to convert this into a heap? You can do that using the Heapify function. So what you do is heapq dot heapify, and then inside Heapify, you mention the list name. So in this case, numbers. Now remember that this particular list right now is not in the heap format, but when I do Heapify, it should convert it into a heap format. Now, what do I mean by that? So let me print that out. Remember how I showed you that in the list each particular number and its children node? So it is going to do the exact same thing for us. So let me go ahead and execute. You can see that it rearranged the numbers in a way that it actually satisfies the heap queue. Now here let's see, 1 is the minimum. Okay, that's correct. And it has two child nodes, 2 and 7. Okay, 2 and 7 are greater than 1. That's good. Now 2 has two children, 4 and 3. Okay, 4 and 3 are also greater than 2. All right, so you can see that it has been converted into a heap. Now, one special quality of heap that we need to understand is that since the parent node is always going to be smaller than its children node, a heap in Python essentially is always a minimum heap. That means that whatever is on the top of the heap is always going to be the minimum node. Okay, so the minimum value is always going to be at the top. I hope that makes sense. Uh, Now I want to show you the methods that are used in heap. So the first one that we are going to look at is actually heap push. So I'm going to take the same example that I have here. So let me grab that. Okay, so say I have these numbers. Um, Let me actually just remove everything. Let me start afresh. Okay, so I have this heap list, and heap push method is used to push new elements into the heap. Okay, so how do you do that? So you do heap q dot heap push, and then inside that you give an item that you, first of all you give the heap list. Excuse me, so the heap list, what is the heap list? This right here that we called heap. So I'm going to give that, and then comma the item that you want to push. You can see that here it's populating that for me, but here I have also written it down. So first the heap list and then the item. So for example, say I want to push 1. So when I do that, and let's say I print the heap, execute, you can see that 1 has been added to the heap. Now let me go and just comment this out. Okay, so you see that 1 has been added to the heap. What if I add another number? Say I add 2 to the heap and I execute. You can see that 2 has been added. Now I have 2 elements inside my heap, and you will see that they are always in the priority queue format. Okay, so that is all about heap push. The next thing that we are going to look at is actually heap pop. What is heap pop? Heap pop is a method that is used to get things out of the heap, okay, to pop the elements out of the heap. So we are going to take the same example. Say we have a heap and then we are pushing 1 and 2 inside the heap. Now what happens when I do heap pop? So heap q dot heap pop is going to return us the element, the item that was extracted. Okay, and what you have to do here is that you have to do heap q dot heap pop and then the heap list. So if I do something called heap q dot heap pop, and then I give the heap name that we have. Now I have to assign it to a variable. Why? Because when it pops it, it has to return it, right? It returns something. So in order to catch it, we are going to get it from the heap queue. So for example, I can say just result equal to heap pop. And if I print that out, what do you think is going to be popped? Here in 1 and 2, what is the minimum? Minimum is 1. So 1 is at the root. And so when you pop it, when you do a pop operation, it is going to pop 1. So let's verify. Yes, so it is giving us 1 back. If you do a heap pop again, so let's say you do a heap pop again, And then the second time, what it's going to return? It's going to return us 2 because 2 is the only element left. So you can see that it returns us 2. So that is heap pop. Uh, Now I also want to show you what is Heapify. So I kind of already showed you this in the introduction on how to define things. So Heapify is going to be used to rearrange the elements inside the list and give you something back. So for example, say if I have, this heap and I push things. So I push 1 and then I push 2. Say I push 2 more elements in here. Say I push 10 and 80. And if I do a heap q dot heapify, you can do that at any instance. So I provide it my list and I print my heap. It is going to just heapify the whole heap. That means that it is going to make it follow or satisfy all the constraints that are there in a heap. So if I execute this, you can see that it has rearranged the elements. One has two children node 10 and 80 and they are greater than the parent node. So that's good. And now, sorry, one has two child nodes 2 and 10. Excuse me there. Both of these are greater than 1. That's fine. Okay, so 2 has 2 has just one children, which is 80, which is greater than 2. Okay, that's good. So that's all about the heapify method. Now I want to talk next about the heap push pop. Now what is heap push pop? Heap push pop, from the name, it suggests that it is going to push an element and then it is going to pop an item. And that is true. That's what it does. So it first pushes the element into the heap and then it pops the smallest element out of the heap. And this heap push pop method is going to be more efficient than you using heap push and then heap pop as two separate statements. Okay, so if you are writing something and you want to push something into the heap and then evaluate, what is the minimum and get that out of the heap, this is the method that you have to use. So here, for example, I already have some heap push in my heap. So for example, now if I do a heap q dot heap push pop, here I give the name of my heap and then the item that I want to push. So say I want to push 0. If I do that, and since it is a push pop, pop always returns something, so I have to catch it. So I can have it in my result variable. Now if I try to print it, so I'm going to just print it. So what's going to happen? 0 is going to get pushed into the heap and then the heap is going to heapify itself, and from this you can see that 0 is the smallest element. It is going to go to the top and that is going to get returned. So this all happens in this particular method. Okay, so I execute this. You can see that it returns 0. Okay, so I hope this was clear. And now let's move on to another method. So the next method we have is heap replace. So this is somewhat similar to heap push pop, but it is here in this case, heap pop is first and then heap push. So what it does, it first pops the smallest element from the heap and then adds a new element into the heap. Okay, so for example, now if I have this, I take the same example, say I do heap q dot replace and then I give the heap list name and then the item that you want to push. So when I do that, since it is a pop and push, since there is a pop, we have to catch the result, we have to get the result. So I do that, and then here if I print the result, here what will happen? It will first pop and then push. So when it pops, here what is the minimum? Minimum is 1. So it is going to return 1 and then it is going to push 0 into the heap. I'm also going to print the heap so that you understand what's going on. So I execute. Oh, sorry. My apologies. It's heap replace. So let's run it. Okay, so you can see that the result we got 1 because it first popped 1 and then pushed 0. And here you can see that in the heap, you can now see 0. Okay, so that is the method. And if you are in some scenario where you want to pop things first and then push things, this is again going to be very more efficient than doing 2 operations. Okay, now I think we have just 2 more left, so bear with me. Yes, so here we have something called nlargest. Now what is nlargest? So in a heap you can get n number of elements that are largest in the heap. Okay, so for example, say you have 1 2 3 4 5 and you want the 2 largest elements from this heap. It is going to, you can use this method and it will give you back 4 and 5. So what is n? N is the number of largest elements you want, and then heap list is going to be the heap. And here key is nothing but a function, so you can actually customize this method in order for you. If you want, say if there is a list and you want to perform certain operation on the list when it's returned, you can do that using this key equal to function. So let me show you what this heap queue n largest is. So I have 1 2 10 and 80 in my heap queue. What I can do is I want to say I want to get the 2 largest elements from this heap. So what I can do is I can do heap q dot n largest, and here I want the 2 largest, so I get say 2 comma my heap list. I don't want to perform any operations on it, so I am just going to do that. And then here in result, I'm going to store it. So I say result. Now I will print the result and see what we got. So run it. Okay, so you see that it returned me a result. It is actually a list where it has 2 elements, 80 and 90. Now if I just change it to, if I want to get just one largest out of it, so I can do 1 and it is now going to return me just 1. It returned me 80. Now say if I wanted to return me 3 largest, I say give me 3 and it gave me 80, 10 and 2. So I hope that makes sense. Now I have a last method that I want to show you, and you might have probably guessed already, since we already have a n largest, we also should have a n smallest. Okay, so it is going to do the exact same thing. The method is n smallest. You give it n, that will give you the number of smallest elements that you want from the heap. You give it a heap list and then you give it a key. Okay, key is optional. You don't have to worry about that. It's for more complex operations where you want to modify the result that has been given to you. So here, let's see. You can do heap q dot, you can do n smallest. Now say I want the 2 smallest from the heap. So I say 2. Then I write heap because that is my list. And since it is going to return me something, I will say result. And let me print out that result. So execute. You can see that it returns me 1 and 2. Similarly, if you change it to 3 and execute, it is going to return me 3 smallest from this heap. So 1, 2 and 10. Okay, so that's all about the methods in the heap. I hope this was clear. If you have any questions, please let me know in the comments section below. You can also join my Discord channel if you want to discuss some things, or if you have doubt about something, or you need any clarification on something. Okay, so feel free to join my Discord. Feel free to let me know in the comments below. If you like my videos, give it a thumbs up, comment below. That really helps my channel. I'm working really hard to make these videos so that this can be helpful to you and you can learn from it and I can learn from it making those. So thank you so much for watching. Give it a thumbs up, subscribe to it. Everything helps. Okay, so I will see you next time. Bye.